Hello, chemistry students. Today we're going to be going over our next lesson in the acid and base unit. Yesterday we went over neutralization a little bit and how acids and bases will neutralize each other when they are mixed together. Today we are going over how to more precisely do that. Our topic is titration. So how can we add an acid to a base or vice versa to figure out the strength or concentration of an unknown acid or base? So we're going to go through this little setup here. Now this laboratory setup is actually the titration setup, and we will have been using this in our laboratories in school. So titration is actually, it is best described as a way to figure out unknown acid and base concentrations. So in titration, a base of known concentration is used to find the concentration of an acid. So what we're going to do is we're going to take the base of known concentration, we would put it in the burette right here, and we would then drop it bit by bit into the unknown acid below. And as we're adding acid to base, what is happening in the neutralization reaction? What is forming here? Yeah, so we're going to be forming water and salt as we mix together the acids and bases. And one more thing to remember is because we're using the word concentration, on table T of your reference guides, you will find the concentration as depicted in molarity or in parts per million. So we want to make sure that you have your reference tables handy so that you can make sure you can do these reactions properly. Also, be sure to have a calculator handy as well. So the different glassware that we use in titration reactions is a burette, which is this long, thin glassware here, where you see the numbers are actually in reverse. So when you fill it all the way up to the 0 marker, you know that you have 50 milliliters locked and loaded into the burette. And then as you open up the valve down here, you get droplets, or a stream will come out of the nozzle and drip into the Erlenmeyer flask. Now, you're going to put your acid or base of known concentration into the burette. And because we know its concentration, we know exactly how much we are adding through the numbers displayed on the burette. And then we are going to put our unknown concentration acid or base, into the Erlenmeyer flask below. As we drip the acid or base of known concentration down into the Erlenmeyer flask, we are going to begin to have a neutralization reaction. And we will also be using an indicator to figure out when it becomes neutralized. So, titration of a base with an acid. What we are going to do here is we would take a base and we would put that base into the Erlenmeyer flask. In this case, we would put the acid up here into the burette, and we would put our base of unknown concentration below. And we would know the volume of the base because we would fill up the base to a certain amount in the Erlenmeyer flask. Let's just say, hypothetically, we put it up to this line at 100 milliliters. We would know, hey, we have 100 milliliters of this unknown concentration of base. And the unknown here, obviously, because we're putting it in the Erlenmeyer flask, the unknown concentration is displayed in molarity with the subscript B, molarity base. Now the acid, we know both of the points for the acid. We know the concentration or the molarity of the acid that we are using, and we also know the volume that we are adding because we have those numbers depicted on the glass burette. And then we would start to drip the acid into the base, and we would start to show a different reaction, a neutralization reaction, where we are forming water and salt. So in titration, when we are using an indicator, Let's pretend that we have a substance in this Erlenmeyer flask. Now we start to drip an indicator into there. And look, as we drip the indicator, we're using phenolphthalein in this example, so we have this flask starts to turn pink. And then as the droplets settle, we notice that the color is actually pinkish. So what kind of liquid is in this Erlenmeyer flask? What substance? Is it acid or is it a base if it's turning phenolphthalein solution pinkish? Yeah, it's going to be a base if it's having the phenolphthalein solution turn pink. Acids would have it remain what? Yeah, acids would have it remain clear. So on your reference tables, make sure you're looking at table T because you're not only going to be using the concentration portion of this, we are also going to be going through the titration formula. And the titration formula dictates the molarity of the acid multiplied by the volume of the acid will be equal to the molarity of the base times the volume of the base. Now, please remember that molarity of H plus or hydrogen ions is the molarity of acid. And just as we went through in our beginning lecture, we went through acid-base theory, molarity of bases is going to be the presence of hydroxide ions. And in this case, for the most part with burettes and Erlenmeyer flasks, we are going to be doing these equations in milliliters. So in question number 1 that we're going to be having in this example is we are going to have a base. We're going to have potassium hydroxide in our burette. And we are going to have an acid. We're going to have hydrochloric acid down in our Erlenmeyer flask. So which one of these do we know definitively both the concentration and the volume? Yeah, we're going to know the concentration definitively of KOH. We do not know the concentration of HCl. We do know the volume though because we're the ones who filled this Erlenmeyer flask up to 20 milliliters. So we know the volume of our hydrochloric acid, but we just don't know how strong it is. And obviously we don't want to exactly put it on our skin to find out because it could be a really high molarity. Now, we do also know the molarity of this base. It's 0.50 molar. And we do know the volume because we filled it up to 32.0 milliliters. So let's set up this equation. First, we are going to take our known variables. The molarity of the base and the volume of the base are two things that we know because we added 32 milliliters of the base into the solution, and we knew the molarity of it when we had filled up the burette. We also know that we filled up the Erlenmeyer flask at the start of this exercise with 20 milliliters of acid. And then we have to have our unknown variable. So we look at our titration formula from the reference tables, and its molarity of the acid times the volume of the acid is going to be equal to the molarity of the base times the volume of the base. So we're trying to get these to neutralize each other or be equal. So let's set up our formula, and we still have our unknown variable for the molarity of the acid, which is down in the Erlenmeyer flask. How are we going to get our unknown variable, this molarity of acid, to be by itself? Yeah, we're going to have to divide it by the 20 milliliters on this side. So we divide it by 20 on both sides, and this 20 will cancel out, but we're going to be ending up with the 20 milliliters down here on the bottom of the bases. So we have the molarity of the base times the volume, and then we're going to just divide that by 20. So what do you guys answer here? Yeah, you're going to end up with about 0.80 molar. of that hydrochloric acid. So now we know our molarity of the acid. And you could actually plug this number back into the original equation to check your work to make sure you did it right, because it should be that 0.8 multiplied by 20 milliliters is going to be equal to 0.5 times 32 milliliters. So let's have you do this one kind of on your own. This time we're going to have the acid on top. We're going to have hydrochloric acid of known concentration and known volume. And this time we're going to have the potassium hydroxide down low in the Erlenmeyer flask. So we're going to know the volume of the potassium hydroxide, obviously, because we're filling up the Erlenmeyer flask ourselves, but we don't know the molarity of it. So that's our unknown variable, is the unknown molarity of the base. So let's take a second and let's get all of our variables together. We have our known molarity of the acid and our known volume of the acid. We do not know the molarity of the base, but we know the volume of the base. So use our former setup, this right here, to figure out where these variables are going to go and come up with an answer for me. See how you do. All right, great job. If you had any confusion about this, I want you to remember that Miss Wong and myself and your other chemistry teachers too, they're available for any of your questions or comments on this material that we're doing right now in class on the acid and base unit. So there's many different ways to comment or to get in contact with us. You could leave a message on this assignment in the comments section, because there's a good chance that one of your classmates might have the same question. So it would be really helpful if you leave a question in the comment section. You can also go to the Remind app and reach out to us there. We're always available via Google Classroom. You can find our Gmail and message us through there. Send us an email. Remember also that if you don't feel like using Gmail, you can use your pupil path and get in contact with us there. Additionally, your teachers are in Google Hangouts, gosh darn near every day. And we're here to help you. So please, if you have trouble with this material, even if it's something small, don't be embarrassed. Come into the Google Hangout. We're here to help you. So I hope that you're able to get in touch with us if any of this confuses you. Just remember that the main portion of this was titration, and we were going over the titration equation that's found on table T to figure out the unknown molarity of acids and bases. But we can find it out, luckily, using known volumes and the known molarity of what we are adding from the burette into the Erlenmeyer flask. Anyway, everyone, hope you have a great day. Please let us know if you're having trouble with this material.